Students, बात करेंगे about one of the most common linear codes that we have, and that is called as the parity check code. Students, parity check code के case में what we normally do is the code word that we produce, it has got the number of bits that are there in the data word, which is k, for example, and then what we do is we add an additional bit. We add a parity bit into it. So students, the total number of bits in our resulting code word is equal to n, and that n is equal to the number of bits in our data word, which is k plus 1. N is equal to k plus 1 in this particular case. Students, this extra parity bit, how do we select this extra parity bit, whether it's going to be a 0 or a 1? We select this extra parity bit in order to make the total number of ones in our code word even. So students, in this particular case, अगर हमारे पास जो total number of ones हैं वो odd हैं, तो our extra parity bit is going to be a 1, so that our total number of ones become even. If the total number of ones is already even, that extra parity bit that we are going to be adding to our code word is going to be a 0. Students, on the slide, what you can see is that we have got a linear code, a parity check code, which has got a value of k is equal to 4, and in this case our n is equal to 5. गौर कीजिएगा, the original number of bits in our data word was 4. We added a parity bit, and so all our code words in this particular case, they consist of 5 bits. Students, in the first case, we had k is equal to 4. So I told you the total number of data word combinations that we are going to have in this case is 16. Then you have your n is equal to 5. So the total number of code words that are possible are 2 raised to the power 5, and that is 32. So n is always greater than k, and therefore once again we have gone through this concept before, your number of code words are always going to be greater than your number of data words. So the 2 raised to the power n minus 2 raised to the power k, this number of code words, they are called as invalid code words. And if the receiver detects any one of these code words, then the resulting code word is going to be discarded, and we employ some sort of error correction or retransmission. Students, गौर कीजिएगा, in the first case of data word, we want to make the parity check code है ये, so we want to make the total number of ones even. In this case, there are no ones, it's already even, so we just add 1 0 to it. Second case, the total number of ones is odd, we need to add a 1. Total number of ones is again odd, here we need to add a 1. It's already even, we add a 0. It's already odd, we add a 1. It's even, we add a 0. Even, we add a 0, and so on. So in the case of a simple parity check code with the number of the total bits in the data word as 4 and the total bits in the code word as 5, we add 1 additional parity bit to make the total number of ones as even. Now students, गौर कीजिएगा, in this case we have got an encoder and decoder for a simple parity check code, and all that we are doing is this generator out here on the encoding side, it is generating parity bit which is given by R0, and this R0 is selected to make sure that the total number of ones, once again total ones, is even. So students, in this the calculation that you are looking at, this is always done in modular arithmetic. It's also called as modulo 2, but to make it simple, this is your modular arithmetic. So as I told you, the encoder is using a generator in this case. It takes a copy of the 4-bit data word A0, A1, A2, and A3, and then the parity bit is added, which makes the number of ones in this code word even, and this is normally done by adding 4 bits of the data word in modulo 2 arithmetic with the parity bit. So students, if the number of ones is even, the result is a 0, and if the number of ones is odd, the result of this generator is a 1. Now, students, on the receiving side, let's suppose that our transmission is corrupted. Then, in this particular case, the receiver will receive a 5-bit word. And in this case, the corrector at the receiver, it does the exact same thing as the generator with one change. And that change is that the addition is now done over all the 5 bits. Exclusive OR addition आप करें over all the 5 bits, and we get a syndrome which is 1 bit. Concept of syndrome is important. If we do modulo 2 addition over 5 bits, these 5 bits that are received at the receiver, you get 1 bit, which is called as syndrome. Students, this syndrome, this is an important concept. The syndrome is going to be 0 when the number of ones is even. And this syndrome, or S0, this is going to be 1, which means that the number of ones is odd. So students, the syndrome is then passed on to this decision logic, which looks at the fact if the syndrome is 0, then there is no error. And so this data word is accepted as it is. If the syndrome is not 0, we simply discard this code word. And students, this is how the parity check code works.